All right. So now we're doing FreeCodeCamp, a Legacy Python for everybody. Iterations Loop Idioms. All right, so let's get to it.
So now we're going to talk about loop idioms. And loop idioms are patterns that have to do.
Okay, let's write this down. There we go. Go to the end, and let's write this down. Loop idioms, what we do in loops. All right, that's a lot more than usual. Let's do this. Loop idioms, what we do in loops. Okay. And note, even though these examples are simple, all right, we can put that down. Note. Let's tab it over one. Note. Pardon me. Even though these examples are simple, the patterns apply to all kinds of loops. Okay. And let's go.
With how we construct. So now we're going to talk about loop idioms. And loop idioms are patterns that have to do with how we construct loops. We have the mechanics of fors and whiles, but ultimately,
let's see what ultimately first.
We want to get something done. We want to solve a problem with a loop.
True. All right. Now let's write this down. So let me get this, and let's see what this is. Making smart loops. Okay. Making smart. I hate punctuation loops. I hate having to type punctuation. Punctuation is useful. All right, here we go. What's this say? The trick is knowing something about the whole loop when we are stuck writing code that only sees one tree at a time. Okay. Let's write this down. The trick is knowing something about the whole loop when we are stuck writing code that sees one entry at a time. What does that mean? All right, let's look at this. Set some initial some variables to initial values for thing in data. Yeah, look for something or do something to each entry separately, updating a variable. Okay, look at the variables. All right, let's try to figure out what this means before he goes and just skips it. So we're going to set some initial variables to initial values. All right, let's see what he says, actually.
And often what we have to do is, if we have a set of things, whether it's lines or strings or characters or numbers, we're looking for something like the largest or the smallest, or we want to add them up or something like that. And so we can't just say add them up. We have to say go through each one and do something to each one and somehow achieve adding them up. And the pattern that we're going to follow is we're going to have this loop that's going to do run once for each thing, right, in some chunk of data. And then, but we're going to set something at the beginning, and then we're going to do something to each one. And at the end, we're going to kind of get the payoff. We're going to get the result.
Okay. So I think this is talking about like when you put the data. I think this is talking about the data for thing in data. All right, let's say we have an array or a list. Remember the things with the brackets? Let's go look at it real quick. Let's say we got like this, like the little bracket like this. Okay, I think the data. I think the some initial variables set some variables to initial values. I don't know what he's saying. Let's go.
So if we're doing sort of summing things, we're going to have a running total. And so this will be like t equals 0. And then this will be t equals t plus the thing value. but this is not the real total, it's the running total during the loop, but at the end it is the real total. And so we're gonna look at what you do at before the loop starts, during the loop, and then what you get after the loop and how you can use that.
Honestly, I don't know why these guys just cannot say this stuff in a manner where it's simple. Because loops are easy. They're really easy, but then you add, what is this, 50 words? There's 50 words on this page, let's say. 2, 3, 4, 5. 50 words. We got 50 words here telling us how a loop works, and it's like, bro, it's just, you just do. Where's the thing at? Here's the loop. Okay, here's the array for friend and friends. We're just gonna do something to each one. We're gonna do the same thing to each single one in order. That's all you gotta say. But these guys wouldn't have jobs if they had to, if it was that simple, right? Right.
So we're going to use this loop. It's just going to loop.
All right, so let's look at this first. All right, looping through a set. So print before. So we're going to have before printed right here. For thing in this list of numbers, we're going to print thing. Okay, just like we've been doing, like with the 5, 4, 3, 2, 1, and then print after this thing's done. So we're going to print 9, 41, 12, 3, 74, 15. All right, we're printing each one of these, and then we print after. It's very, very simple stuff. All right, it gets complex later, but right now it's easy.
Loop through a set of 6 numbers over and over and over again, right? So we're going to do something before the loop, we're going to do something after the loop, and then we're going to run the loop some number of times. And in this case, thing is our iteration variable because I'm using unmnemonic variables now. So it's going to run 9, 41, 12, 3, 74, and 15. So it's going to run and print these things out. So it runs this loop 6 times, and away we go. Now this loop does nothing except print stuff out. Of course, I like to do that first, is always print things out to make sure that sort of my brain is functioning.
Cool.
So to kind of understand how these loops work, I'm going to ask you to function as a program. And I'm going to show you some numbers in succession. And I want you to mentally figure out what the largest number is, but more importantly, think about how your brain is solving this problem of what is the largest number, given that I'm only going to show them to you one at a time for a little while, and your brain has to do something. And imagine I was going to show you thousands of numbers. I'm not, but imagine I was. How would you organize yourself in a way so that for like an hour and a half, you could sit here as I showed you numbers and you keep track of the largest number that you've seen of all the numbers. Okay, so here we go. Here's your first number.
3. All right. Remember
Second number.
That's larger. 41's
Third number.
No.
Fourth number.
No.
Fifth number.
Yes. 74 is now.
Sixth and last
Nope.
number. What was the largest number?
74.
Hmm?
Did you
What was
answer?
it?
Did you answer 74?
Well, it wasn't too hard. It was 74. But
Oh.
that's not the question. How did your brain arrive at 74?
I'll tell you how I did it. Well, as we were looking, 3 was in my mind first, and then the next one was whatever, 12. I don't know. And then I said, okay, 3, you're out of here. 12, you're him now. 9, 4, 3, 2, 1, whatever. No, none of you are bigger than 12. 74 comes around. You're him now. 12, you had a good run. You're out of here. 74, you're the man now. Next, 15, whatever. 74, you're the big guy. All right. And that's how you do it. You say, I remember you're the biggest. And then you're the biggest now. You replace that one. Right? Right.
So here's all the numbers. If I'd shown you all the numbers and asked you what's the largest number, your eyes would have sort of gone, and then you got to 74. And you wouldn't do it in any particular order. Your eyes would just like see the 74 and it would just throw smaller numbers away, and it would move really quickly to what the answer is. Even if there was several hundred numbers on the screen, your mind would sort of move fluidly wherever it felt like moving and then arrive at it. And probably what it would do is it would do something like kind of move like this, find this, and then sort of check to make sure that it's okay, and then say like, okay, I got 74, I'm done. That's not how computers do it. That is not how computers do it.
Not at all.
They do not move fluidly. But they are highly dedicated. They're going to do something. 74. But how would you construct a loop to achieve this?
Easily.
So let's take a look. You could create a variable called largest so far. And this is the largest variable, the value that you've seen in the list so far. Now, I haven't shown you any numbers yet. So we'll just set this to -1 to get us started. So now we see 3. And we're like, oh, that's better than
-3's the winner
1.
now.
It's our first number, so it's probably the largest we've seen so far, right? Great. 41. Oh, that's bigger than the largest we've seen so far, so we'll keep it. 12 is not bigger than 41, so we're not going to keep it. Notice this keeping thing. 9 is not bigger than 41, so there's no point to keeping it. 74 is bigger than 41, so we'll keep it. Is this the largest number? We don't know. We don't know until we're done. 15, not better than 74. So now we're all done, and hooray, 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 we have the largest number. And we had this variable that we kept the largest number that we'd seen up to this point. And then when we know that we're done at the end, then that becomes the largest.
True.
So if you look at all the numbers, keeping track of the largest so far, at the end of all the numbers, the largest so far and the largest are the same thing. And so that's how you get this idea of something you're doing during the loop is not really the answer, but by the time the loop is done, you will have the answer. And so here's a bit of code that does this.
Let's look at this, and let's actually type this down. Why don't we? Get a little practice. We didn't do the one before, and we haven't been really typing a lot in this video. We need to get our typing on. Let's do it. All right. What does this say? Finding the largest value. Finding the largest value. All right. We'll start here with a little tab over, and we'll say largest so far equals -1. Right. So we're declaring this variable largest so far, and this is another reason we want to type it out, because we want to get used to this snake case, right? Because it's actually kind of hard to do. It's hard to hit these number keys, in my opinion. Maybe you're a genius at typing. Me, no, not so much. Print. Let's put these, and let's say before, comma, and then largest so far. Yes, so that's what we're printing first. We're printing the variable -1, all right? 4, so now we're starting the for loop here. For the num, I don't like that variable name, but it is what it is. And then let's put these brackets here. Let's do 9, comma, 41, comma, 12, comma, 3, comma, 74, comma, 15. I'm doing that no look, by the way, because I got to get my practice on. It is Codeman has practice videos, by the way, or blah, 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 whatever. Let's go. All right, so now we're going to have this thing right here. Let's tab it over twice. If, so this is the keyword if, the num. So this is the variable the num. I don't know why all three of these are the same color, but whatever. If the num is greater than largest so far, all right? So if whatever num we're on is greater than largest so far, what we're going to do is now say largest, come on. So come on, far now equals the num. All right. And we're going to, outside of the if statement, print. And then let's put largest looks, the more I type these words, the stupider they look, I swear. So look at largest so far. Language is so stupid, but necessary. Largest so far, the num. Okay. So it's going to print largest so far and the num, which, okay, so even when it replaces it, okay, so it'll do that. And then we'll come down here and outside of the for loop, we're outside the for loop now, so it's on the same line or the same column, whatever, print, and we'll print after, and then we'll say largest. So far. Okay. So, oh, do we got to type this too? Should we type this too? Yeah. I want to though. It's so much. 1, 2, 3, 4, 5, 6, 7. 7's good. Yeah. So this is the program. So whenever you see the $, Python largest. Oh, Python is calling the program. Oh, come on. Python largest.py. So that's the program name, largest.py. Tab, 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 tab. This is the first print before -1. All right. Tab, tab, tab. 9. So it's printing out largest so far, the num. Okay. So this first one, the first one, we're replacing it already. So this is replaced to the num. So we're saying 9, 9 here. All right. Then we're doing 41, 41 because 41 replaced 9. Then we're doing 41, 12. And it didn't change because 12 was not bigger than 41. And then we're doing 41, 3. Didn't change because 41's not, because 3 is not bigger than 41. We got 74. 74, and it did change, all right? So that's where we can see it change when it's the same two numbers. Then 74 and 15 did not change because 15 is not bigger. And then down here we'll say after 74. So this is what the loop's doing, and this is what the loop is, all right? So it's like, I mean, it looks complex if you don't know, but once you start getting into it, this is actually much simpler than actual like language, because it's just like we keep saying, it's just a command. We're just telling this box with electronics going through it how to do something. It's not a thinking human. Even a cat is more complex than a computer. Okay, computer's very simple. It's just like you keep saying, they're very dedicated, but they're not alive. Remember that too. So yeah, that's how this one works. Let's write this stuff down at the bottom too while we're at it. Let's do a hyphen in a space. We make a variable that contains the largest value we have seen so far. True. We make a variable that contains the largest value that we've seen so far. True. If the current number we are looking at is larger, it is the new largest value. True. Largest value we have seen so far. Also true, right? So that's it. That's it. It's very simple. I mean, it looks stupid and it looks hard, you know, at first when we don't know what we're looking at, but once we understand what we're looking at, it's really simple. And this is all it's doing. If the current number we're looking at is larger, we turn it into the new largest value we've seen so far. That's it. So let's hear Dr. C talk.
Use it with our numbers, right? So let's take a look. So I have this variable called largest so far. I set it to -1. Before the loop, remember there's a loop before and a loop after and a loop in the middle. Before it's -1. So now the num, remember underscores are okay, that's my iteration variable. If 9 is greater than largest so far, well, largest so far is -1, so that's true, so this code's going to run. So we're going to remember the new number. So this is 9, and so 9 ends up in largest so far, and then we print it out. And so largest so far is 9, after we saw the number 9. Then we do it again. So now 41 comes in. And is 41 greater than 9? The answer is yes, it is. So we're going to run this code, copy 41 into 41 into largest so far, and then print it out. And largest so far is 41 after we saw the number 41. Now we're going to run the loop again with 12. Okay, and you get the idea, I hope. Is 12 greater than 41, which is the largest we've seen so far? And the answer is no, it is not. So we skip. So the largest so far stays 41 even though we saw 12. Meaning we're sort of like ratcheting up, but we never ratchet back down. So we run it again with 3 and 41, and we skip this, and then the largest so far is 41, even though we just saw 3. And now we see 74. Is 74 greater than 41? See, we never are looking at all the numbers. We're only looking at the window on the numbers of the current number that we're looking at. So is 74 greater than 41? The answer is yes. So we run this code, and then we capture the 7.
They just love saying things unnecessarily complex. The window, right? Come on, it's just this number in the loop. It's this instance. It's this element. So you don't have to say window or go crazy. But what do you want?
74. So we just saw 74, and it is the largest so far. And then we run it again with 15, but 74 is our largest so far, and so it skips. So 74 remains largest so far after 15, and now we're finished because we just ran the last thing. The for loop takes care of everything and jumps to this print statement and says afterwards, largest so far is 74. But at this point, it's also the largest, right? So largest so far became largest when our loop finished. So that sort of gives you this notion of how we construct.
It became the largest when the loop was finished. I mean, true, technically. I mean, yes. Although I think it became the largest when we replaced it, but it's a matter of opinion, but whatever.
Construct, something at the beginning, some kind of thing that we're going to do over and over and over again, and then something at the end. And we put some print statements in just so we can watch it and see what's going on.
True.
So coming up next, we're going to talk about some more loop patterns, some counting, totaling, averaging, and finding the smallest number.
Turning 8 minutes and 25 seconds into 22 minutes. All right. That's the Codeman-esque way. All right, so here we go. Below is code to find the smallest value from a list of values. One line has an error that will cause the code not to work as expected. Which line is it? Ooh, let's find out. So smallest equals none, true. Print before smallest. Is it this one? Is it line 1? No, it's not line 1. All right. So for iterver in this, if smallest is none or iterver is less than smallest, smallest equals iterver. Okay. And then we're going to break out. We will print loop, break out a loop right here, 6. Because if it's none, we're just going to break out. Or if it's smaller, we're going to break out. Because if we break out of the loop, we're done right then and there. So it'll go, if smallest is none, which it is, or itervar is less than smallest, smallest is iterver, break. So right off the bat, it's going to break. So let's say 6. Let's click the button. All right. Submit it. All right. So there's that. Now we're on to iterations, more patterns, and we'll see you next time.